interruption. This software is free software, and they limit the recording time to 10 minutes, so I had to stop it. So I wanted to generate a model that can do these three cases. First, this one. If I do this, this generated a pulling force of 24.7 Newton. Say we are making this kind of product, then we need to calculate how much the force we need to have this with this, in between this. Maybe we need to first know how much weight is this. Then we need to design pulling force that is greater than the weight of this. Imagine if this is like a fish. And this is like a fishbowl. Then, with given the pulling force, if we divide the Newton by gravity, this in this position, if this fish is greater than 2.44 kilogram, then you cannot catch the fish. If the fish is like 2.3 kilogram, you will eventually catch the fish. So I want to see if we can do better if the magnet gets closer to iron. I want to decrease the air gap length into half and run it. Now it's 57 Newton meter. So it has a greater ability to catch fish. Maybe this fish can be 5.8 kilogram. Also, I want to test. Okay, see this magnet size. If I change it to 50, you can see the magnet got bigger and the force got bigger. So now it's 7.5 kilogram, 74 Newton meter. So we verify that if this magnet gets closer to iron, the magnet pulling force is bigger, and if the magnet size is bigger, even greater force there will be. So we now have model. For the next, I want to vary this, given this model, vary this air gap length in this manner, incremental mm, I want to uh, turn this into a function with uh, input variable of 1, 2, 3, 4, 5, 6 input variable and one output variable. So I did this, made some changes. For example, I replace these things with a variable, and now I can call the function from other script. So here I have this variable for geometry input variable. Then I will change the air gap length. So if I run it, they will generate the you can see the air gap is increasing. Sorry, there was an error in my code. So if I do run this model with different input variable, I will you can see the increasing air gap and decreasing force. So if I draw this, you can see maybe I should label it label air gap length in millimeter, y label pulling force in Newton, well, so in this video you learn how to generate model, use the model with a different input variable, and save the result to draw the thing. Now this is labeled. You can see as the magnet gets closer to iron, you will get more pulling force. Maybe beyond the air gap length greater than 16-18 millimeter, you will not feel the pulling force anymore. So that means you need to get this air gap should be less than, say, 12 to catch the fish of 1 kilogram. You will never get chance if the thing is far each other. So next time we will learn how you're gonna use this model to optimize.